that's here in Blacksburg. It's a company that I started and my wife runs. And what Heliotext does is it creates ultra-secure turnkey text analytics systems. So ultra-secure means we place systems into our clients, the US government, for example. Turnkey means we supply hardware and software. We put the whole thing there. Text analytics means we can compare one contract to another contract, for example. So there might be problems in the literature that we would put into here, but the US government and other places are interested in knowing if two contracts are too similar, because they could be paying for the same thing twice. Okay? And we have installed that system, and it does business intelligence, marketing, grant, and contract evaluation. And our biggest customer is the National Institutes of Health. Now, the National Institutes of Health in the United States is responsible for handing out $38 billion worth of grant money each year, okay? And they get submitted 90,000 grant applications a year for that money. And unfortunately, some of those grant applications are identical to other grant applications, and that's what our software discovers. And it allows the National Institutes of Health to make a judgment when a grant comes in and they look improper. They never even send them out to review. They discuss them in-house. Okay. Sorry for my voice here. So let me tell you about ETBlast. So this is the engine if you went to etblast.org. And this is what you get. You get a place here where you can put in a paragraph or a whole paper. You can select databases that you would like to use. This is Medline, so it has 20 million biomedical abstracts. NASA papers for science, space science. Archive, which is a database of physics, math, engineering, chemical engineering, chemistry, things like that. It's very large as well. Clinical trials, that's information about medical trials for drugs. And medical cases, this is about people's reports. There's about 1 million medical cases where it's a report about a person who had a particular disease and what happened. Okay? So, you can put in your text here, pick a database, and hit search. And then you get these results almost instantaneously. It compares all the words in your query and finds, by ranked order, what are the most similar abstracts in the database that you chose. So this one, I happen to be looking in the medical database, and so this is the most similar, next and next and next. The other thing is, this gives you some other things that will analyze all this data. An important thing is, you had a query, and it found this, so this is a possible reference. So if you're writing your paper in chemistry, then you might want to go and read this paper, because you put in your abstract. This says, you should read this paper. Then you know something you can add to your paper. Now, however, there's something else you might want to do. If you look at all the papers that are similar to this one, I mean not too similar, but related, you can see who are the authors of these papers. If you hit Find an Expert button here, it compares all the names and figures out who wrote most of the papers. Okay? Why would you want to know that? Okay. Well, if you're writing a paper about a chemistry issue, maybe you would like to call an expert and say, I'm working on this paper, but I'd like to have your opinion on my hypothesis. How do you figure out who's the expert? You put your paper into our engine, you run it, you hit Find an Expert, and it will give you a list of the people who wrote the papers that are most similar to your idea. Then you can call them. By the way, if you're writing a paper and submitting it to a journal, most journals require you to submit a list of possible people who could review that paper. Who do you know who would be an expert in that field who can judge your paper? So, you do that. And by the way, there are lots and lots of journals who use this to do exactly that. They find their own reviewers. If you're a scientist, you're a scientist, and I give you a problem. I say you have to cure cancer by analyzing microsatellites in genes. Well, you might want to go and find out who's an expert to talk to, but you might want to go and find out who's our competitors. Who do you not want to talk to? Okay, that's it. That's it. Now, when we actually compiled all this, these 80,000 highly similar documents, they were deposited in our database called Deja Vu. Now, this is online and available, and here's some of the totals. Here's that 80,000 total. 79,000 papers are in this database, pairs of papers. The other thing is this database has statistics, and you can look at the distributions of the papers by language. How many are in English? How many are in Chinese? How many are in Romanian? By country, okay? Is it from the United States? Is it from Mexico? Is it from Japan? So there's a lot of statistics that you can see about highly similar behavior. Here's an important thing. There seems to be no bias by country or by language or by anything. So it doesn't say that people from America are worse than people from China or vice versa. What it says is, by human nature, there are going to be some fraction of people who don't do good things. And it doesn't matter where you're from, unfortunately. So that's in the statistics part, and it might be interesting to explore that. If you go to the browse part, you can go and look at these pairs of papers, and you might want to bring them through that sometime, just to explore it. Show it to them. Okay. Now, once you have a giant database, the purpose of a database is not to just store information. The purpose of a database is to store information so you can then question the database about things and have those questions give you have a query give you big observations. So we did that. We actually did we took a part of the database. There's about 8,000 papers that are very similar and whose authors are not the same. So early and latter paper have different authors. So they're potentially plagiarized papers, right? Just like you found, I think. So that's too many for us to study. How many did you study last week? How many paper pairs?
One each, so that would be 19. Yeah.
19. So it took you...
And then there was two or three people did an extra one.
Okay. So it's 20 papers in a day. It'd take you a lot of days to do this number. So we did a small sampling, so we have a statistical estimate of what's going on. So we did 206 pairs of papers that were highly similar out of 8,000. What we did is we compared those papers, and we compared them line by line like you did. And for example, here's a paper, a latter paper, that what's marked in yellow is a part that's identical to the earlier paper. You can see, other than the author list and stuff, it's almost all identical. So we provide that in the database. That's a thumbnail sketch of what was done. That's in the database. So what we did was, we did a study, and this was our study that was published in Science last year. We took 206 pairs of these, we did this analysis, and we sent emails out with the original paper and the latter paper. Latter paper was annotated like this in color. And we sent it out to all the authors of the earlier paper, and of the later paper, and of the editors, early and later. Okay? And all we said was, can you explain this? Okay? Is this okay within policy? We didn't accuse anybody of anything. We're asking for information.